So we have this handout. It's the same problem that we had before. So regenerative vapor power cycle, etc. This time what I'm going to do is I'm going to also solve it with the isentropic efficiencies for the turbines. Down here they're listed, what is that, 75.56 and other values. And also I'm going to try to do it in Excel. So this is where we were. We had the plant layout, had states 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12, then 13. One of the trickier parts that we did last time was did a mass and energy balance around the closed feed water heater to get an equation for Y prime, that mass fraction diverted down to the closed feed water heater. Here it was in terms of the enthalpies of state 11, 10, 2, and 12. All right. So you can get the enthalpies at all of these states and then get the mass fraction. Sometimes you have to work hand in hand, get most of the enthalpies, then a mass fraction. But in this case, you can get all the enthalpies, then get the mass fractions. And then Y double prime, doing energy balance around the open feed water heater. And you'll find Y double prime as a function of the enthalpies, but also Y prime. So those are the equations we had last time. Last time we tried to sketch it on the diagram, a TS diagram. You need to get good at that as well. So what I'm going to do now is you have the problem in front of you. And I'm going to jump to a clean Excel sheet, a brand new Excel sheet. So here's Excel file. It's a brand new sheet. Inside I have add-ins such that if I wanted to evaluate an enthalpy as a function of some pressure and temperature, I can do that. You're going to want to get that add-in. So if you go to the Blackboard page, our class Blackboard web page, I loaded up the project that's due October 1. You can look at a PDF file. It's the same thing that I'm going to hand out in paper. Also, you have an add-in and an add-in, the steam tables.xlam. That's the Excel for the add-in. That's one you'll want to use. You do not need to know or use the gas tables next chapter, but if you want them, I just put them up there. A student put together this help file. It's a PDF. He said that he had directions how to do it on a MacBook. So how you can run Excel with the add-ins on a MacBook. So if you're a Mac person, there you go. Otherwise, put it on your laptop or your desktop PC. So what you do is you download those. When I click that, it'll download here. I then grab that file. I usually do something like this. I'll do open file or show it in the folder. I'm going to show, maybe this is not in the folder anymore. It's been removed. I'll do the download here. Boom. So we'll do this real time. So it's downloading it again. I've done this once already. And then I'll go ahead and open in a folder or show in the folder. There it is. I cleaned out all my downloads, so that's the only one. I usually then cut it. Whoops, I don't want to do that. I want to select it and cut it. Then I want to go and put it in a place that I'll remember. I like to put it in the C drive in a brand new folder that I called add-ins. If you don't have that folder created, then I would recommend you stuff it in there. So I open it up, then I'd come here and I'd do a Control-V paste and put it there. All right, now, as you could tell, I already have a bunch of these in there. You'll have, if you want, selected gas tables in this one, H2O, thermal. All right, now I'll go to the Excel file that I opened, go under File and tell it where that add-in is. So every time I start Excel, it'll be ready to use. So go under File, and down here you have Options. Under Options, you could come under, you can look at all this, but you basically go to Add-ins, click Add-ins. Now you won't have a list here because I have a lot of add-ins, probably too many. But come down here, Excel add-ins, yep, that's what we're doing. Hit go. And now you won't have all this list, it'll be short. If you've never done this before, I recommend you click the solver add-in. It's already, Excel ships it with you. But for some odd reason, it doesn't activate the solver add-in. And how many people have ever used solver? A couple? It's worth using. It's a good tool. So go ahead and click that one, my recommendation. It's not needed for this assignment. But you won't see the one. You have to go hit browse right here. Now you have to remember where you put it. So now you got to go to C drive. There's that add-in folder. And then you would select it. Now I've already added it in. But if you're doing it for the first time, you would select it just like this and then hit OK. I'm going to hit cancel. Because once you do that, it'll show up. Then you'll say OK. And then you're done. You're ready to go. So let's do this. We're going to solve this problem. So I'm going to make a bunch of states, just like I laid out on the chalkboard last time. So we'll start with state 1. You have the diagram in front of you. You can see that 2 is after the turbine. So I'm going to put 2S and 2 actual. Why? Because when I analyze a turbine, first I go isentropic flow through it, and then I use the isentropic efficiency. Right away, this column I like to put like centered so that they line up, so it's not jumping around from the left side to right side format. Then we go back for reheat at state 3. Then 4S is the next turbine after the second turbine stage. Go back for reheat. Then 5S and 5 actual. And then we go take a look. I got to look at this diagram myself. It's 5 after reheat, then 6S, that's right, and then 6 actual. And then we go back for more reheat. So then 7 is the condenser, going into the condenser. 8's coming out of the condenser. Then 9 after that first pump. Then 10 going into out of the open feed water heater into the second pump. Then 11 is compressed liquid going out of the closed feed water heater. And then 12 is the condensate, and 13. So you have to have a good grasp of all your states where they're at. Okay. Next thing I like to do is I like to list pressure in kilopascal. You can use bar, you can use megapascal, but the routines I'm showing you, the default pressure going in is kilopascal. That's one I prefer. I like to use temperature in degrees C. I like to put in a column for quality. I like to put a column for specific volume, which I only use 2 or 3 places, meter cubed per kilogram. I like to put in an enthalpy column, which is the most important column. We need that one. And an entropy in kilojoules per kilogram Kelvin. And you can put in a flow exergy. You can put in more. But let's go ahead and populate. So we come out at 8 megapascal or 8,000 kilopascal at a temperature of 440 degrees C. We would like to evaluate the enthalpy of that superheated steam. So you type equal sign, then H is the starting letter for that enthalpy call. The format is to do an underscore, then the 2 independent intensive properties here, pressure and temperature. And the way that we created the routines, it's P first and then T. You can't put T then P, just PT underscore. And you can see Excel's trying to help me finish it off. Do you want to use table A4 or for water or ammonia, table A15? You won't have all those options, refrigerant, but here, this is one. It's A4. You just remember, oh yeah, A4 is superheated table. So I hit tab to accept that one, to finish it out. Then I go over and select the cell for the pressure, hit comma, select the cell for the temperature, hit close paren, and hit return. And there it is. Now, I like to format stuff right away for the whole column. So I'll come down and I'll format everything to have 2 after the decimal place. 2 digits after the decimal place, so all the enthalpies look good. Okay, you can do the same thing. S underscore pressure temperature. You can see, okay, let's go finish it out by moving to the right one, and then hit tab, and then select the pressure, comma, temperature, close parenthesis, and then hit enter. All right. Now I don't need the specific volume, and quality is not defined. If I try to say, okay, give me the quality as a function of pressure, temperature, it's not going to work. There's no routine. It's only defined in a 2-phase dome. So some things, just by lack of having a function, oh, I can't do that. Well, now that you kind of get a sense of how to use the routines, let's first finish out this column for all the pressures. That was pretty easy. It was 2,000 after the turbine. And then I like to use the equal and then refer back to, and then the equal and then refer back to. Why? Because one of the beauties of Excel is if I go ahead and change this entry in this column, then it updates in other columns. But if I type 2,000, 2,000, 2,000, well, I have to go and replace 3,000, 3,000, 3,000. But let's go back and put 2,000 back again. And so that's your pressure during the reheat and after that first turbine stage. Then we go down to 300 kilopascal after the second turbine. I could type it or do equal sign and go select that cell. Now 6S, we're going to drop down to 6 kilopascal, down to 6, down to 6, and 8. 8 is after that first pump, so that's back up to the 300, and coming out is still 300 at state 9, and then state 10 is after the pump. What's the pressure after that second pump? Can you tell? It's all the way back to 8,000, isn't it? All the way back to 8,000. And then 11's 8,000. Now, state 12 is the condensate out of the bottom of that closed feed water heater, and that's going to be at my 2,000. And then it goes through the trap to the pressure of the open feed water heater, which is 300. So again, if I do it like this, then I can come in and change, make 3,000. Or what did I do? Put 3,000, 1, 2, whoops. It'll change that pressure here as well as over there. Okay, so good. Now, we have the inlet pressure and temperature. There's one other, isn't it state 11, where they tell us that temperature? And that temperature is 205? Yeah, all right. So let's go back to the top and we'll work all the way down. So state 2, it's isentropic, so I'll copy down the entropy. And so I know the pressure and the entropy. This is my style. I'll first evaluate the quality, giving it pressure and entropy. And I would need to use table A3 because that's the pressure index. Tab, so pressure, comma, entropy, PS. And it comes back with the 1.0457. Well, that's above 1. It's superheated. That's just a numeric way of saying, oh yeah, it's not in a dome, it's superheated. So when I come over here to get the enthalpy, I'll get enthalpy as a function of pressure and entropy using the water, but I need to use table A4 for superheated. And so I'll get the pressure there, and I have to kind of click a box and then grab it and slide it underneath. I'm just not that good at Excel, okay? But I'm trying to select the box underneath the label. All right, now that gives me the isentropic. Over here, what I like to do is I like to put what is the work out of the turbine if it's isentropic expansion. Well, that's going to be the change in the enthalpy. So I would get up to 356.93 kilojoules per kilogram. But the efficiency of the turbine for this problem is 75.56%. So 0.7556. I can leave it as a fraction, or I can change it percent and maybe move out 2 decimal places there. So the work turbine actual is going to be that isentropic multiplied by the efficiency. This is my style. I like to do it this way. I like to have all these to 2 digits. And this is already the 2 digits, but I like to make sure it's 2 digits. So now I can go to the next line for 2 actual, because the actual enthalpy is the enthalpy coming into the turbine minus what is that work out of the turbine. Good? Does that look okay? You follow that? Good. If I wanted to, I could get an S now. I could get a temperature now. But I don't really need to. What I can do is probably right now is, if I wanted to know the temperature, I would play the game and I'd say, what is the quality given the pressure and the enthalpy? Go to table A3, boom, comma, boom. It's not going to be, it even went more superheated. It didn't get closer to get inside the dome. But I can use that to say, okay, if I really wanted to know the temperature right here, I don't need it, but I would say, give me the temperature as a function of pressure and enthalpy using table A4, pressure, enthalpy. How many people already recognize that would be a hard calculation by hand with some serious interpolation? Well, the student, Matt Rivera, worked with me on this years ago. He's gone, graduated. He's out there doing something. And it took us a while. But basically, we are doing inside of Excel the exact interpolations that you would do by hand to do these steps. So this, too many digits here. Let me clean this up. Whoops. There. Notice that I picked this efficiency such that it was on a temperature line in table A4 for that pressure block. That's why that efficiency is picked to 4 digits. All right. Now let's say you go back for reheat. It goes back for reheat. It comes out at 360 degrees. Well, I like to do this. I like to make notes to myself over here on the side. So the pressure and the temperature were independent, and I used table A4. Then it was the pressure and the entropy were my independent properties. And at first I used table A3 to determine if it's what the quality is. And then I may use A3 or A4 depending on what the quality value is to get H. All right, so these are the same here. Pressure and enthalpy either using A3 or A4. All right, but the pattern is back again. What we do is we're just going to repeat it after reheat for the next turbine. One of the beauties of Excel is once I have the cells used, I just copy that 2 cells and paste them. And what they do is it's now using the reference, the ones over in column E and F that align for that row 6. Likewise, this one. And once I get that, then I can say, well, I'm going to do this step too. Just copy, move it to right here, paste it. Now it's complaining. Can you see that? Why is it complaining? Well, because the quality was in state 2S is superheated, but now it's 0.999. Guess what? It doesn't like trying to look that up. So the entropy copied, no problem, But this enthalpy, I don't need to use table A4. What I need to do is put an if. So I'm going to say if the quality here is less than 1, let's do this. I think it's easier if I do it this way. If I say it's greater than 1, comma, go ahead and use the function already built. But if it's not, comma, that's now the second option, go ahead and get enthalpy as a function of pressure and quality using what? And you can see it's going to recommend. I'm going to say using table A3. So if it kind of read this if then else. If it's greater than 1, oh, it's superheated, used A4. If not, hit tab, use A3. Now I have to feed it the pressure, comma, and that quality. Then I hit close paren to finish the call, and then I hit another close paren to finish the if. Now it'll work. Yeah. Now, because I built a more sophisticated enthalpy calculation based on the value of that quality, I can copy that cell, come up here and update that one. So all I did was do a paste, and now it's... How many people have used Excel? Yeah, isn't it nice? All right, or you can do this in MATLAB or Python or whatever. There's a lot of routines out there to do these type of calcs, but I find Excel pretty easy. I can come down here to this next line, and I'm going to copy that one, copy, and I'm going to paste it right here, boom. And what it did was it calculated the actual work out of the second turbine, but I have to update that efficiency. It's not 75, it's 86, 86.85%. There it's updated the value on that efficiency for the turbine. So this is updated. We come over here. Oh, look it. Isentropic, it's right on the line, 0.999. That's a quality, just a skosh under 1. It's that saturated vapor. But when you have some isentropic efficiency, it kicks that out a little bit, and you're slightly superheated. We take a look at this one, and yes, we're still using the right table A4 for that. But we could update that temperature calculation as well. Let's say that we drop this to, I don't know, not 300, but 500. It'd be superheated, both of them. Let's drop it to 200. Well, it's very close to 1. Here, let me do it 150. It'll make it more distinctive. You can see that both of these now, they're both in the dome. So this temperature is no longer any good because I shouldn't be using table A4 for that temperature. So I'm going to do the same thing. I'm going to say if this quality is greater than 1, yes, use table A4 as we did already. Otherwise, comma, go ahead and get Tsat as a function of pressure for the water out of table A3. So I select it, hit tab, and then do that pressure, close paren, and then close parenthesis again. So the actual temperature's here. Now that I updated that one, I'm going to go back and update this temperature right here, but it won't change the numeric value. It's still 280 because I'm doing the first if. 300 is our actual pressure. There we go. Let's go to state 5. Well, what was state 5? It's reheat back to 320, right? Okay, so you're basically redoing these steps again. Just copy and paste it down. So I'm going to go ahead and I'm going to copy this 2 cells for getting the enthalpy and entropy. I'm going to copy all of these cells for getting the quality. And then the work, I need to update the efficiency for that turbine. It's 64.30%. Whoops. Oh, great. Fine. 0.6430. There you go. Now, we see that it's 2-phase. Let's go ahead and bring down this one. boom. So it's superheated. You can tell there's the temperature and there's the enthalpy. And if you double click on it, it exposes the formula and highlights the blue cell and the, what is that, orange cell. So you can look at your formulas. Now, state 7, isn't that out of the condenser? So I make a note that it's saturated liquid. So I really am interested in the pressure, the enthalpy. So I know the pressure, so I'm going to get H of F at the pressure for water using table A3. If I want, I can go ahead and get the temperature, saturation temperature as a function of pressure for water using table A3. And so, interesting, it went into that condenser at 80 degrees. It comes out saturated liquid at 36. Right away, you could probably say, I want to have that, I want the quality to be 0.99, 0.98, 0.9. You could start to see how to optimize the system, how to prove it. Okay, you're bringing in superheated vapor in that condenser for this problem. Okay, let's continue on. What about state 7 to 8? Isn't that a pump? So what I do is I come over here just like we had for the work of the turbine. I'm going to put work pump isentropic. What is my minimum work of the pump? Isn't that VDP? Sure. You know what? I'm going to move that a little above. So this is where I need the V. It's the specific volume of saturated liquid as a function of pressure using table A3 at 6 kilopascal. You check, that looks reasonable. So the reversible work of the pump is the product of the specific volume of the liquid coming in times the change in the pressure. Well, it's going out at 300 kilopascal. It came in at 6 kilopascal. And that's one of the reasons I like the kilopascal and meter cubed per kilogram. It's no additional unit conversion in that. That automatically goes to kilojoules per kilogram. We go ahead and put the efficiency of our pump in. It was 0.9. So let's show that as percent and move it over. So now what is the work pump actual? Well, it's the isentropic divided by the efficiency, not multiplied. So it takes a little bit more. So instead of being 0.30 kilojoules per kilogram, it's 0.33 kilojoules per kilogram. Now I get that enthalpy right here. It's this enthalpy coming in plus the additional work added. Pumps, that's how I handle it in Excel. Are you with me? All right, let's continue on. What about state 9? Well, state 9 is after the open feed water heater, and it's about ready to go into a pump. So just like state 8 was saturated liquid, state 9 is saturated liquid. If I made a note to myself, I would say that this is using V times dP to help get state 8 as a note to myself. I'm using the work of the pump to get that enthalpy. Okay, so hey, we've done another of these already. I'm going to just copy all of this down because I want the specific volume of the liquid at state 9. Likewise that. They refer back to this pressure of 300 kilopascal, refers to the H of F at 300 kilopascal. I use a 90% isentropic efficiency, so it looks like 9.18 kilojoules per kilogram is what's added. I can even just copy this cell and paste it, and there you go. That's my, well, I didn't do that correctly, did I? Control Z, undo. There. I copy this cell, move it down 2 places, paste it. All right, so this is my V times dP to get state 10 figured out. What about state 11? Well, it's a compressed liquid. Look at that high pressure. Even though it's high temperature, it's still compressed liquid. We're going to need to use table A5. I need to get more room in this cell. Double click, make it a little wider. All right, so I need the enthalpy as a function of pressure and temperature. And most of the time I go superheated, but you can go to table A5, which is compressed liquid. And this is the pressure and this is the temperature. Okay, all right. State 12, isn't that saturated liquid coming out of the bottom of the closed feed water heater? So how do I, basically it's just like state 9, I can just copy this cell for H, boom. Okay, how about for state 13? It's isenthalpic, so H13 equal to H12. So I just copy that enthalpy down, H. Once I know all the enthalpies, sometimes this problem I can get all the enthalpies without knowing the mass fractions that are diverted to the open and closed feed water heater. Sometimes you have to kind of iterate. Oh, I can get so far in enthalpies. Now I got to get that Y prime or Y1 or Y2. Depends on your problem. This problem, I could get all the enthalpies. I can insert additional columns over here. Insert. And I'm going to stick over here my calculation of Y prime. All right. Well, this is where you had to do the work before, right? So Y prime was the H11 minus H10 over H2 minus H12. So I have to calculate H11, so I come enthalpy state 11 right here, minus the enthalpy at state 10, close parent, divide by, open parenthesis, H2 right here, minus H12 right there, close parenthesis, and it looks like it's around 14.88%. There you go. And then I have another one, Y prime prime, and we already talked about what the equation was for that. So that's a little bit longer. It's going to be H9 minus my H8 plus my Y prime, so I need that, times the difference between H8, subtract H13, okay, close the parenthesis for the numerator, divide by, open parenthesis for denominator, H4, that one, minus the H8, which is right there. Hit turn. And it looks like it's 11.29%. I like to also calculate 1 minus Y prime. You can do that right away, 1 minus. So it's like, 85.12% continues on for that reheat. And then I also like to calculate the 1 minus Y prime minus Y prime prime, which is 1 minus this minus that. So for every kilogram that goes into the first turbine, only 73.84, that fraction or that percent goes through the condenser, so I kind of know how the mass is splitting up as it flows through the system. I have a table of the properties. Maybe I clean it up, make it a little pretty bold, and maybe I center these, and I don't know, increase font size if I like, whatever you like to do. But I need a table of the components. So for each component, I just list my components. I have first turbine. I have the reheat 1. I have the second turbine. Reheat 2. A third turbine. Then didn't we go to the condenser? And then we went to pump 1, then pump 2, and then the steam generator. Those are the components that have energy transfers, either Q's or W's with the surroundings. The closed and open feed water heater are no shaft work with the surroundings and no heat transfer with the surroundings, so we don't put them in the list. I like to put a column for the mass flow rate divided by the mass flow rate going in the first turbine. What is that? Basically, I have how many kilograms, it's the mass flow rate going through that component divided by the mass flow rate. So for the first turbine, I'm going to put this in symbols, 1 minus y, no, that's 100%, right? And because this is going to be equations, I'm going to center it. And then for the reheat, 1 minus y prime. How about for the second turbine, 1 minus y prime? How about for the second reheat, 1 minus y prime minus y prime prime? Why am I doing this? So I minimize the chance that I make an error. That's why I'm doing it. Okay. And then I have, I'm going to copy this cell because that's what goes through the third turbine, through the condenser, and through the first pump. What about the second pump? What goes through the second pump? Is it back to 100%? Keep us on track. Okay. Now what I like to do, now that I have the equation, I like to actually put in the value. Why do I do it like the equation and then the value? Because it's so error prone. I'm telling you, this is so error prone. But I just come up here and I'll get the 1 minus y prime, 82%. And then I'll get that one, and then I'll get the 73%, and then the 73%. And then it's a little tedious when you first do it. It's like, why am I just having this table filled with the same numbers? Well, again, I want to avoid errors. So I can put, whoa, that's a bad looking one, isn't it? All right. I can put this like all percentages and then move over decimal place. Makes it look good in my opinion. Now, I'm going to have Q, and then I'm going to have Q asterisk. Then I'm going to have work and work asterisk. So these are in kilojoules per kilogram that goes through that component. And this is kilojoules per kilogram that went through the first turbine. So likewise, this is kilojoules per kilogram that goes through that component. And this is kilojoules per kilogram that goes through the first turbine. All right. Now, half of that column are zeros. Let's go ahead and figure it out. For the turbine, any heat transfer? No. Any heat transfer to second turbine? No. Third turbine? No. Pump? No. No. There you go. So now we just have to say, what is the heat in the reheat? Well, I look at it, it's going to be the difference in H's. Sorry I have to scroll, but maybe you have a bigger computer monitor at home, but this is the size I've got. I'll have to do some scrolling here. I have to go up and I have to get H3. Right here is H3. And I subtract off H2. And that is how many kilojoules per kilogram that went through that reheat. Let's finish out this one. So it's going to be for the second reheat is H5 minus H4, correct? So let's get H5 minus H4. All right. Then we have the condenser. I want this to be negative because it's heat out of the working fluid to the surroundings. So I know it needs to be negative, and it's going to be the H7 minus the H6. And I stop, I pause, I look at it, it's negative, I'm happy. And then I come down to the steam generator. That's a big positive heat transfer in. It'll be the H1 minus the H, not 13, but 11. There. Did I do that right? Good. Now the next column, All you do is take the value in this column and multiply by that mass fraction. And then you just drag the formula down. Everybody know in Excel you grab that lower right corner and drag down and it populates. So basically it's this formula is copied down. And what do I want to do right here? I want to do the summation of everything here. And if everything works right, the sum here, that's too many decimals, is going to match the sum on the other one. So let me just take a look here for a minute. Why do I have so many digits? All right. Did I do the condenser correctly? Take a look at the condenser. 7 and 6A. The condenser. 7. Did I do that right? 6A. 2801. We had numbers last time, didn't we? I don't think I had that number last time. What did I do different? This is always challenging when you're doing it live. That's why people love PowerPoint. It's not lecturing, it's reading PowerPoints. All you got to do is click and read it, click and read it, click and read it. This is a little more challenging. I'm looking for why I don't have the same answer that I anticipated. Okay. Did I mess that up? That's equal to, isn't it, for the condenser? We have H6 going in, H7 going out. So it's equal to H7, 151.53, minus H6, 2650.11. And I have the correct value now. I don't know what my error was in the formula. Did somebody see my error before? I must have had 2 negative signs in front of both terms or something. But I had an error in the formula. I can go back and probably find my error. Should I do that just for illustration purposes? Go back. See, that's not the same answer. So I look at the cell. I got to zoom in, but it doesn't allow me to zoom. Okay, fine. But I think I put negative. So I think I need to get rid of that negative sign. There, now it's right. You know, one negative sign can drive you crazy, can't it? So, but we're going to check. Let's do the works. So when you do the work, there's nothing for the reheat, nothing for the condenser, nothing for the steam generator. But let's figure out, we want a positive work. You know what? We already did that. That work, the first term, is right there. Done, right? Whoops. Equal to that one. And then for the second turbine, come on now, let's work. It's this one. And for the third turbine, it's this one. Now the pumps, I've been working with the positive work into the pump, but because I'm going to do a summation here, I really need the negative. So I force it to be negative, and I'll put a negative forcing it right there. Now I don't sum that column. I first get it on the right, or the same per unit mass basis. So I'll take this work times this mass fraction. All right, too many digits. I'll copy that formula down. If I want to, I just copy this over because it's just doing a summation of the column. So the sum of the W asterisk and the sum is equal to the sum of the Q asterisk, or work net equal to Q net. Let's say I came in here and I had my error. I didn't see that minus sign. Well, guess what? Ain't gonna work. I know to look for an error. So let's go back and fix it again. Get rid of that extra negative sign. And now they match. Maybe I make it bold and increase the size because I'm so happy. So now we have this. I clean this up a little bit. Maybe make it bold, increase the header, maybe make it in the center. Wow. Maybe add a box around it. I don't know, whatever you want to do. What do you make Excel look pretty? Maybe, maybe not. It's up to you. And there were two questions that were asked of us. Maybe I want to come down here and answer them. What is the back work ratio? Okay. Well, it's going to be the sum of the two works that go into the pump. I got to get rid of that negative sign. So I'm going to add this one plus that one, divided by the work out of the turbines, the sum of the works. Notice that I'm using the same per unit mass basis. You have to. And it's not that much. 1.01% back work ratio. Great, we love that. Low. Then the thermal efficiency of the plant. Well, what's it defined as? We want the work net per kilogram going through that first turbine, and we divide it by all the heat in per kilogram going through the first turbine. So it'll be the reheat plus the reheat plus the initial going through the steam generator. And we find that that's a reasonably good value of 33.3%. Real happy for those. Bold them, make them big, put a big box around it. I don't know, big box, I don't know. Something. You're happy. So there you go. I wish I could fit it all on one screen, but it's not, I couldn't do it. Any questions? So how do I get these functions set up? I'll just summarize again that you go and create an add-ins folder in a C drive, my recommendation, and then you put the download from Blackboard into it, open Excel. Under File in Excel, you're going to go down to the bottom, Options. Once Options, you're going to say Add-ins. Then it's going to say OK. And then you're not going to have a bunch of stuff in there. Maybe you'll have Solver add-in highlighted, but the rest is not going to be there. And you'll just say Go. You browse to find that add-in in the C drive. Once you find it, you select it, hit OK, and then it'll show up and it'll have a little check mark by it, and you'll say OK, and now you're ready to start using it. I see some people with laptops. Had anybody already get it to work? 1, 2, 3, 4, 5. I'm impressed. Pretty good. If not, Sean will be available. I'll be available. Did you help any people this morning? You did already? Very good. With that, I'm going to shut this down